Hello, welcome to Ludic Science. In this video, I will talk about the classic square wave generator using the 555 IC and how to make it on PCB using the services of PCBcalm. This is the circuit of the 555 timer connected in a stable mode, which means that we will have at the output a train of square pulses. The amplitude will be controlled by the input voltage, and the frequency and width of the pulses is controlled by these two potentiometers and this capacitor. It is very convenient to have your circuit on PCB. Of course, there are many ways to make your own PCBs, but it is also very cheap and easy to use the services of PCBcalm. Ordering your PCBs online is very easy. The first thing you have to do is to design the circuit on an electronics software. You can use the one that you like the most, and this is in order to generate the Gerber files of the circuit. The Gerber files contain the instructions to fabricate your PCB. Once you have the files, go to the page PCBcalm, and if you have not registered, click on register, add your name and address, and then click on login. After login, click on calculate, and in this page you can upload the files. Click on add your Gerber file, and once the files are uploaded, you will see on the screen a picture of your circuit, the way in which your PCB will be fabricated. Here in this page you can adjust several parameters like the dimensions of the PCB thickness, color, the number of PCBs that you want, etc. When you're happy with your parameters, click Save to Cart, and then you will see the total price without the shipping cost. At this point, click Checkout Securely, and here you will add the shipping info, the address where you want the PCBs to be sent, and also the shipping method, which can be DHL or registered air mail. After that, just click on Continue and pay for your order. And that's it. When the mail arrives, we have our PCBs. Let's see. Okay, here it is. A perfectly made PCB. We now can put the components and solder them to the PCB. Here's the PCB with all the components soldered in place. So let's now test it. Each single pulse of the train is composed of two times. T1, which is the time when we have an output, a voltage, and T2, which is the time when the voltage is 0. The value of T1 is given by this expression. Note that it depends on both R1 and R2, which are the values set by the potentiometers and the capacitance. On the other hand, T2 only depends on R2 and the capacitance. The period of a pulse, the total time, is the sum of T1 plus T2 and results in this expression, while the frequency, which is the reciprocal of the period, is given by this expression. And here's the circuit working. It is connected to the power supply and the oscilloscope. and we can clearly see the train of square pulses on the screen. The first potentiometer corresponds to R1 and the second to R2. Remember that if we vary R1, it affects only T1, the width of the pulse. But if we vary R2, it affects both times, the width of the pulse and the time during which the signal is 0. Let's see. I'm going to vary R1 and you can see how T1 is varying, but T2 remains constant. Now if we move R2, we can see how both times are changing. By adjusting both potentiometers, we can select a particular frequency and also a duty cycle, which is the ratio of T1 to the total period of the wave. Okay, that's all for today. I hope you liked the video. Thanks for your visit and see you in the next video.